2.2.1 Trends in chemical properties of alkali metals. Number 1. Low ionization energies makes the alkali metals the most reactive family of metals. Number 2. Very high second ionization energies indicate that the oxidation number higher than 1 are ruled out of alkali metals. Number 3. The cations of alkali metals have low charge and large radii than the radius of any cation from the same period. So the lattice energies of their salts are relatively low. Consequently, most of the simple salts of the alkali metals are water soluble. Most of the salts are dissociated completely in aqueous solution, and the hydroxides are amongst the strongest bases available. Number 4. They react with oxygen and the surface is tarnished due to oxides formed. Only lithium burns in the air to form normal oxide, Li2O, which is white solid, lithium oxide. 4Li plus O2, 2Li2O. The exposed metals are oxidized almost immediately by the oxygen in the air, and in the presence of moisture, the oxides formed react with CO2 in the atmosphere to form carbonates. Li2O plus CO2 gives us lithium carbonate, Li2CO3. Sodium will undergo a similar reaction but only if the supply of oxygen is limited. In the presence of excess oxygen, sodium forms a pale yellow peroxide. 2Na plus O2 Na2O2. Sodium peroxide. Potassium, rubidium and cesium react with oxygen to form superoxides orange and yellow. Cesium explodes spontaneously when it is in the contact with air or oxygen. Potassium superoxide K plus O2 KO2. Very rapid reactions occur when alkali metals react with water. A small piece of sodium, potassium or lithium floated on water reacts vigorously to liberate hydrogen and produce metal hydroxide. The reaction is highly exothermic and the energy produced by the reaction may even ignite the hydrogen. 2Na plus 2H2O gives us 2NaOH plus H2. The reaction becomes increasingly vigorous from lithium to cesium. Potassium, rubidium and cesium are so highly reactive that they react with ice even at minus 100 degrees Celsius. Alkali metals form hydrides with oxygen. Number 6. 2M plus H2, 2M plus H minus, rubidium and cesium react violently with hydrogen at room temperature. The other three metals require elevated temperature in order to form the hydride. Lithium and sodium hydrides are useful to sources of hydrogen when treated with water. LiH plus H2O, LiOH plus H2. Due to the presence of hydride ion, the ionic hydrides are used as powerful reducing agents. Number 7. Lithium is the only group 1A element that combines with nitrogen and carbon to form nitride and carbide respectively. Lithium nitride and lithium carbide. Alkali metals react easily with halogens to give halides. Lithium and sodium, for example, react slowly with chlorine at room temperature. Molten sodium burns with a brilliant yellow flame in a chlorine atmosphere to form sodium chloride. 2Na plus Cl2, 2NaCl, potassium and rubidium, cesium react vigorously with all the halogens, forming metal halides. All alkali metals form their sulfides when treated with molten sulfur. The general reaction is 2M plus S to M2S.